Calcitriol is a form of vitamin D that is produced through actions of the skin, liver, and kidneys in that order. So I'm not concerned about you knowing the chemical conversions that happen in each of these, but do know that it begins with those keratinocytes in the epidermis that we've talked about in the integumentary system, using UV radiation to convert a pre-vitamin D to vitamin D, cholecalciferol. So it's vitamin D3. Then the liver is going to take that vitamin D3, add a hydroxyl group, and convert it to calcidiol. Then the kidneys are going to take calcidiol and convert it to calcitriol, our ultimate vitamin D that we need. Calcitriol is going to raise blood calcium levels, so it can increase blood calcium levels 3 ways. It can increase the absorption of calcium by the small intestine. It can cause resorption from the skeleton of calcium, so it basically stimulates new osteoclasts, which then are going to break down more bone and cause us to resorb or take out calcium stores from the bank, so to speak. And it can also promote the reabsorption of calcium from the kidneys. So it can tell the kidneys, hey, keep that calcium, don't excrete it. Calcitriol is also going to help with deposits of calcium into the bone or into the bone bank. It helps to provide calcium and phosphate. If you don't have enough calcitriol, you can get too much softness in the bones. Again, kind of like when we talked about before, that balance of inorganic and organic materials. If you take away too much of the minerals, then you're going to get too much softness. In children, we see this with something called rickets, and in adults, it's a condition known as osteomalacia. Calcitonin is another hormone involved in calcium homeostasis. Calcitonin is produced by a particular set of cells called the parafollicular cells. These cells are found in the thyroid gland, and when there are high levels of calcium in your blood, then the parafollicular cells will produce and secrete calcitonin. What calcitonin then will do is lower blood calcium levels, and it does this in 2 ways. It can inhibit osteoclasts, basically saying, hey, stop breaking down bone. We don't need those minerals released into the blood. And calcitonin can stimulate osteoblasts. Get rid of this excess calcium, make some more bone, put some more matrix out there, so it will deposit calcium into the bone bank. This is really important in children. It's not as important, or it doesn't work as much in adults. The osteoclasts are way more active in children because there's a lot more remodeling going on, as they are having a lot more changes to the stresses they're presenting to the bones as they grow. And the final hormone is parathyroid hormone. Parathyroid hormone is secreted by the parathyroid glands, also of the thyroid, but it's not the parafollicular cells, so you'll want to keep all of these straight. They're separate. This is released when there are low calcium levels in the blood. And how parathyroid hormone can raise calcium levels is in 4 different ways. It can first bind to receptors on the osteoblasts, which then will stimulate osteoclasts to resorb bone or break down bone. It can also promote calcium reabsorption by the kidneys, so there's not as much being excreted. PTH also promotes that final step of calcitriol synthesis in the kidneys, which will increase the calcium raising effect of calcitriol. And finally, PTH can inhibit collagen synthesis by osteoblasts, which will inhibit bone deposition, which in turn, of course, means that you're not putting as much calcium into the bone. So it's going to, in turn, raise those blood calcium levels. Here's just a figure I want to walk you through as negative feedback in calcium homeostasis. The blood levels of calcium can depend on the movement of calcium in and out of the bone. And again, this involves the parathyroid hormone or calcitonin. So if you have a decrease in calcium levels in the blood, then you get a release of PTH or parathyroid hormone, which through 4 different mechanisms can increase calcium levels by increasing osteoclast activity, increase the reabsorption of calcium from the kidneys, increase vitamin D production, and so then through calcitriol can raise blood calcium levels. If you have an increase in calcium levels in the blood too high, then this can trigger calcitonin to be released. Calcitonin will then decrease osteoclast activity there and increase, in some cases, osteoblast activity. So you have more bone being made and less being broken down so that calcium goes back into the bone bank.